Okay, welcome. So the very first topic you'll be discussing in the material once you start the class is infrastructure. And that means talking about the motherboard. So I'm going to show you what document we're using when we discuss things in the curriculum. There's something that CompTIA publishes, and it is called the exam objectives. You'll hear me refer to this a lot, exam objectives. These are the exam objectives for Tech Plus, and basically it's CompTIA telling you what you need to know for the exam. Now, what we're going to be discussing in this video is the motherboard, or what's called the system board sometimes, and that's on page 5. I'll include these exam objectives so that you have access to those and you can see as you begin your studies. All right, so the motherboard. This is, well, before I get into a description here, words to keep in mind. It could be called the motherboard, the system board, or a printed circuit board. So that last one really describes what I'm about to explain to you. We have two analogies we can work with here. The first analogy is a city and the grid that goes into making a city. If you ever look at a map, you can see the streets and the grid of a large city or even small cities. But that grid is what gives you the ability to drive around or to walk around. So that's the city streets or the city sidewalks. Electricity is delivered along these routes on a motherboard, as well as data. So if you could just picture a city and the grid that makes up that city, that's really what a motherboard is doing. Or you could use an analogy number 2, and that is a body. So a body holds all of the organs, blood, and bones together so that we can walk around and live our lives. The blood is obviously delivering oxygen and other things throughout the body. So if you use the body analogy, then when we get to CPU, you can also think of that as the brain. Either way you go, these are the 3 words that are sometimes used to describe the body, or excuse me, the motherboard. Okay, let's talk about form factor. Real simple. That's jargon, tech jargon for size. That's it. Form factor means the size of a motherboard. And we have 8 sizes here that are pretty common. The very first one you do not even need to know. This is old time. This is like the 1970s, 1980s. But from ATX on down, you do need to know these form factors. Now, I usually say you need to know these in size order or at least know what they're used for. So keep in mind, this is something that you'll need to know. ATX is the standard desktop build. Micro ATX is a thin build, or it could be for a gaming PC build. Mini ITX is a small form factor. Notice here, ATX, ATX, now we switch to ITX. The last 5 are considered ITX, which means small form factor. So they're used in things like cell phones, tablets, maybe you have electronic equipment in your car. They can be used for some of the desktop sets, like if you have Xfinity or some sort of streaming service, you probably have a small form factor inside of the equipment that gets you the service. So keep that in mind. But these are our form factor sizes. You do not need to know size dimensions like 6.9 inches by 4 inches. You only need to know the sizes in order, as well as what they're typically used for. So I'm going to ask you in the homework below to find out what these last 4 are used for. But let me just tell you a quick story for how I memorized the motherboard sizes. And, I love to use stories, patterns, and images. In this case, I have a story with images. So if you've ever seen the movie Boss Baby, picture that baby in Boss Baby exiting the garage door and hopping on his ATX. Now he's kind of tired. He's just woken up. He's got on a big old droopy diaper. He's got a big head, big baby head. He gets on his ATV, a 4-wheeler. That's what I think of when I see ATX, ATV. So Boss Baby hops on his ATV. There's a huge microscope on the back of his ATV. And that microscope looks like that Pixar lamp that jumps across the screen in the beginning, lands on the eye, and then looks at looks at you. Think of that microscope looking like that lamp. Why does he need a microscope? Because he has to find his very small car. What is his very small car? It's a Mini Cooper. It's very small. He can barely see it. He can fit in it, but he can barely see it. Um, he couldn't drive it home last night because he was formula drunk. He drank too much formula. So as he's leaving the garage, he starts driving down the windy driveway, and Neo from the Matrix jumps out. Neo, if you don't know who he is, go look him up. And he says, "Dude, you got to call your Nana." Now think of Nana as Nano or Nano as Nana. You got to call your Nana, your grandma. You made amazing pico de gallo. She'd be so proud of you, and you got to tell her about it. Pico de gallo. Okay, so Boss Baby pulls out his mobile phone. It's probably a flip phone from the early 2000s, and he starts dialing his mom. That's the story I've used to memorize the sizes. If you come up with a better story, it's going to be a lot easier to memorize these, but you definitely need to know what these are used for in terms of build. All right, moving on. What's on the motherboard? There's a lot on the motherboard, but I just want you to know about these three things for starters. The CPU, which we can call the brain or the CEO, RAM, which stands for Random Access Memory. Think of it as an executive assistant. PCIe, which is peripheral, what is it? Peripheral connects in or something. I don't even know what it stands for anymore, but it is Express, PCI Express. So that's used for growth and expansion. And that's basically for installing newer devices into the system, into the computer. You want to have that expansion ability. Okay, so if you can think about these three as those concepts there, that's going to help you remember what does what. So the CPU, we have all different types of CPUs. Again, you do not need to know everything right now. I just need you to think of it as the brain or the CP or the CEO, my bad. So when I put something into the computer, I might type it, I might click a mouse, I'm talking into a microphone right now. I might touch the screen if this were a touch screen. When I put that information into the computer, the CPU is processing it. And its sole job is to process my command and give me output. It could be something in the speaker. It could be a printout. It could be something displayed on the screen. So that's what the CPU does all day. In order to do that, it needs RAM. It could not do its quick calculations without RAM. RAM is passing scripts and information to the CPU all the time so that it can produce the output it needs to. So that's why it's like an executive assistant at a company, like sits right next to the CEO. They're always in the meetings. They're giving the CEO everything they need so that they can do their job. And then finally, PCI Express. This is used for growth and expansion. Let me give you an example. Let's say you decide you want to buy a system knowing that later on you're going to be a PC gamer, or excuse me, a gamer. So you want to probably at some point install a new graphics card that's better, has lower latency. It has a nice cleaner look. So you're going to use the PCI Express slots to do that. You don't want what came with the computer, you want to grow and expand. So here is your homework. Okay, we went over a couple of things here. We talked about the form factor sizes, size order, and then we talked about these three components on the motherboard. I want you to research what Neo ITX through mobile ITX are used for, these four. Okay, I want you to research these four. What are they used for? And if you can take a look at pictures, look at pricing, so you kind of have an idea. You don't need to know that for the exam, but I want you to build your contextual learning. Um, Next, I want you to look at RAM. There's a specific type of RAM, it's called DDR. And I want you to look at the generations of DDR RAM. So there's going to be a number associated with it. DDR RAM with a number. I want you to put it in order from oldest to newest, and you will know what I mean when you look them up. Number three, I want you to look at pictures of these items. I want you to look at a picture of Neo ITX, ATX, CPU types, RAM types, PCIe. I want you to see those pictures so you understand what they look like. You know, it's hard to picture them without looking at them. And then finally, try to learn this to teach this. Okay, you're starting at square one, so I don't want you to know DDR speeds, pin counts, notch placement. I just want you to look these things up to understand them. So lastly, I'm giving you a situation. Your manager says we need a new desktop for a graphic designer. The designer works with Adobe Creative Cloud. They occasionally edit video, and they want the computer to be pretty powerful. The only drawback is they don't have a ton of desk space. So you're already thinking form factor sizes, but your manager also said, hey, I'm going to give you some specs on this. Mid-tower case, we have a budget of $1,500, and the requirements for this build need to be met. So that means dedicated graphics card. Again, think about what she's using it for. 32 gigs of RAM, capable. Maybe it's not currently installed, but capable. So think about RAM bank count, and look that up if you don't know what that is. What do I mean when I say RAM bank count, or the number of slots on the motherboard? Okay, look that up. And then you need future upgrade potential. So my three questions are, can we use ATX? What form factors can we use if we can't use ATX? And then find a motherboard that meets the requirements above. All right, I want you to find an actual motherboard. So I went over a lot in this video. If you have any questions, just let me know. But here we go. Let's get started.